In this video, we shall prove this theorem which helps us to find the order of an element in a direct product. Theorem says that if G is the direct product of H and K, then the order of an element HK is equal to the LCM of order of H and order of K. This symbol is for LCM of two numbers. So let us prove the theorem. Suppose LCM of order of H and order of K is S and order of HK element is T. Now let us take the power S of this element HK. This will be equal to H to the power S and K to the power S. But because S is the LCM of order of H and order of K, so order of H will divide S. So that means H to the power S will be 1. Similarly, K to the power S is also 1. So both these are 1. So we get 1 1, which is the identity element of H cross K. So that means this element HK is killed by this positive integer S. So its order of HK must divide S. So that means T divides S. On the other hand, if we take HK raised to power T, which is 1 1, we get that H to the power T, K to the power T is 1 1. So that means H to the power T is 1 and also K to the power T is also 1. That means order of H divides T. Similarly, order of K divides T. And if both are dividing T, then their LCM is also dividing T. So that means S divides T, and so these two are equal. S is same as T. The theorem can be generalized to direct product of any number of groups. So if G is the direct product of H1, H2, Hn, then order of the element H1, H2, Hn is equal to the LCM of the orders of all Hi's. As an example, we consider the group that is the direct sum of two cyclic groups Z25 and Z5. Let us count the elements of order 5 in this group. So we take an element of order 5 in this group, but order of AB is simply the LCM of order of A and order of B by the theorem. So this is equal to 5. Now these two are positive integers, both of these two, and their LCM is 5. And LCM of two positive integers can be 5 in the following three cases. Order of A and order of B both is 5. Second case is that order of A is 1 and order of B is 5. Third is that order of A is 5 and order of B is 1. So we discuss these three cases one by one. In case 1, order of A and order of B both are equal to 5. Remember that A is coming from the group Z25 and B is coming from Z5. In Z25 there are 4 elements of order 5 and these are 5, 10, 15 and 20. In Z5 also there are 4 elements of order 5 and these are 1, 2, 3 and 4. So A has 4 choices and B has 4 choices. So overall we have 4 times 4, 16 choices. So we have 16 elements of this type where order of A and order of B both are 5. Second case is that when order of A is 1 and order of B is 5. In this case A has only one choice. A can be identity and B has the same 4 choices as before. B can be 1, 2, 3 or 4. So in this case we have 4 elements of order 5. Similarly in the case 3 we have order of A 5, order of B 1. So here B has one choice and A has 4 choices. So in this case also we have 4 elements of order 5. So overall we have 16 plus 4 plus 4, 24 elements of order 5 in the group Z25 direct sum Z5.